Okay, so for our mid-month virtual series, welcome everybody. I'm glad to see you could take time out to talk about things digital with David Snyder. He's a principal engineer at Palo Alto Networks. David is a self-described network audiophile. He has over 30 years of experience designing, supporting, and managing computer storage and networking infrastructure for large corporations. His interest in high-fidelity sound reproduction spans 4 decades, and the emergence of streaming audio in the last 10 years resulted in a convergence of these two fields. David enjoys helping other audiophiles achieve greater success with streaming audio by guiding them towards a reliable infrastructure. With a solid foundation in place, folks spend less time troubleshooting and more time listening. And isn't that the aim of digital? David has been presenting and educating folks on digital for 25 years. If you remember, in the SF Audiophile Society days, he presented his in-depth slideshow in, I believe, February of 2020. And David was also a presenter at this year's Expona. Let's see. For tonight's presentation, David will focus on digital networking system architecture. He plans to speak for a few minutes. We'll mute the mics, as I mentioned, and then open up to discussing optimizing home network for music streaming. David has some familiarity with various streamers and digital equipment, but not an expert with all. So he will limit his discussion to the equipment he has experience with. So without further ado, go ahead, David.
All right, cool. I see that I am unmuted, so I will take it that you can all hear me and that you can see what I'm sharing you. You should see a slide with a little picture of a funny-looking guy at the bottom corner. So with that, so this is kind of a hybrid of a talk that I did for the Arizona Club a couple of years ago that I've updated a bit, and also some of the stuff that I talked about at Expona this past April. One of the things that I really want to try to help people to do is get to the place where streaming works as much as possible, as well as putting a CD in your CD player. And I'm going to be taking folks, from what I understand, the folks here are kind of starting at streaming from different places. There are some folks who've been doing streaming for quite a while. They've been, in fact, that's the only way that they listen to music, or the primary way. And then there are other folks who have listened to internet radio on their phones or played stuff on YouTube, but don't really have their home system and an internet streaming solution integrated together. And so what I thought I'd do is run through a few of the slides that I prepared to introduce folks to the topic, just to kind of level set everybody and get us all to the same place. And then I'll take some feedback if it seems like this is too much of a review. The reason I want to do this, though, is for me, when I take a look at 2025, where I'm coming from, it feels like streaming's a solved problem, that everybody's doing it to various degrees, and a lot of folks are having great success, and some are encountering some problems, but it's not that a majority of audiophiles are unfamiliar with the concept of streaming. And so normally I would start this presentation a little bit further along, but I'm just going to run through some example introductory stuff to get us all on the same page. So what is streaming? I call it playback via progressive download. So progressive download means instead of downloading an entire song or track or album all at once, we just download little bits of it. Maybe it's like 10-second segments of it, or whatever. Different technology uses different kinds of ways of chunking up the music as it comes down from streaming providers. But it's a progressive download. So there's download happening at the same time that the music's playing. Music starts right away. You don't have to wait for an entire song or entire album to download. There's some caching, but the content's generally not stored permanently on the client. And it can be lossy or lossless. We tend to prefer streaming services that provide at least Redbook CD level playback quality, since we're audiophiles, and audiophiles care about quality sound reproduction. And then one of the things I like most about streaming, I've got friends that are all over the country that enjoy listening to music, and we'll be texting with each other or on the phone with each other, or they'll send an email and say, "Hey, David, you've got to check out this new album or this new release by one of our favorite artists or whatever." It's great to be able to say, "Hey, have you heard this new release of Steely Dan album or whatever it is, or maybe it's a newer album that from a newer artist," and I can just immediately start playing it, and we can even synchronize our playback if we want to, kind of manually, and then talk back and forth and say, "Hey, what do you think about this part, or what about the bridge?" We can discuss music in real time. I don't have to go out to Amazon or to a record store, buy the album that my friend is trying to tell me about. I can just play it immediately. And this, our hobby tends to be very solitary, but being able to engage with each other in a almost real time kind of way, I think is really, really neat. On the video side, like Amazon and other places, Netflix have done these watch party types of things, and I kind of wish streaming providers would do that as well. But we're not so far from that, and streaming enables us to share these music experiences that would otherwise just be very solitary. And then, I don't have to go into all these other things you can read for yourself, but there are a number of advantages for streaming that allow you to access music that you just don't have or can't keep in your collection, or you can't justify. And then, one of the problems that people are concerned about is there's this notion that streaming is somehow not as good as CD, and we'll talk more about that later. There are cases where that can certainly be true, and we'll talk about some of the reasons why that could be. But it's not a delivery problem. There are other aspects of sound quality that could make streaming sound better or worse than CD, just like any other format. And then, some of the limitations, I guess the biggest and most frustrating one, and the reason that I still buy CDs pretty regularly, even though I have subscriptions to a couple of different lossless streaming services, is you don't know the provenance of the album. Sometimes on a streaming service, they'll say this is the 2013 remaster or whatever, but a lot of times they don't. And sometimes they'll change the version out from underneath you. It's whatever the studios are providing the streaming services, that's what they stream up. But they may not have like the original release of Dire Straits. They might have a remaster or something that has dynamic range compression that the original did not. And so if you really care about having a particular version, or maybe you want a Mobile Fidelity Sound Lab master that's not likely to show up on a streaming provider's website ever, if you want a particular version of an album, then you kind of have to go out and buy it. And then, artists and streaming services can get into spats, and the artist can yank their content. So there's some kind of, negatives that go along with streaming, but it's you gotta kind of recognize what the limitations are, and then, supplement with vinyl or with CD or what other media in the cases where you really care. For most of us, digital audio started out with like this old Sony CD player. This was actually the CD player that I had decades ago. And I wanted to touch on how CD transport typically works, just because it kind of illustrates some of the problems that we're trying to solve with streaming. So this is kind of the inside of a CD drawer. And what happens is the hub kind of lifts the CD off of the tray, because otherwise when it's spinning, it would scrape, right? And then there's another hub that kind of couples on top of it, and then they rotate together like this, if you can see my hands. And because the CD is suspended by just the center, and it's spinning, it starts out spinning at 500 RPMs. The laser tracks from the inside of the CD to the outside of the CD, instead of vinyl records that go from the outside to the inside. Starts out spinning at 500 RPMs, and then depending on how long the CD is, it'll slow down to as much as 200 RPMs. That's pretty fast, and since it's only just clasped together on the hub, the CD itself can vibrate if it's not perfectly balanced or perfectly centered. And sometimes, with some CDs, you'll hear it more than others. You'll hear those mechanical vibrations in your CD player if you put your ear to it, especially when it's reading the table of contents. Now, if you think about it, a traditional CD player has also the DAC components inside of it. And so now you've got this mechanical vibrations plus whatever noise the power supplies is experiencing by having to drive the CD and spin this wobbly disc around. So there may be some back EMF or other kind of electrical things that are happening inside of the CD player itself that have to be isolated from the delicate analog circuits on the DAC chip. It's just like a hostile environment, mechanically, electrically, to produce good sound. It's really kind of amazing that CDs worked as well as they did. Back in the previous century, somebody came up with a brilliant idea of solving this vibration problem by separating the DAC and the transport. So you have the noisy bits, if you will, the CD flopping around and vibrating, and any electrical noise that's associated with that running in one device, and then a separate external DAC that presumably has its own power supply and has a quieter operating environment that will provide that isolation and produce better results. And so this is, kind of how we got to where we are today. In today's world, instead of using a CD transport, we use what I call a network audio transport or a network bridge or something like that. And this is kind of the simplest example. This is just a little Raspberry Pi, but it illustrates all the different components. And if you go out and buy a streamer, it'll have kind of all of these components in it. A streamer is essentially a small computer like this with some additional circuits, possibly a DAC and some analog circuits and a display and other things wrapped around it. But when you boil it all down, they all have a little computer, if you will, like this, that's tucked inside of them. So music comes in over the network and it goes out over, in this case of this device, over USB, but you could have a card that allows it to output SPDIF or other kinds of digital formats. But essentially, it's this basic, instead of having the music coming in through a laser pickup reading from a disk, it's just coming in over the network. Otherwise, it's functionally the same thing as the CD transport. And then this is an example of one that has coax SPDIF outputs. And then you can buy some prepackaged devices. This is the Hi-Fi ZenStream that was pretty popular not too long ago and still a little bit popular. That has network in, and again, USB or coax SPDIF out. Digital to digital converters are becoming a bit more popular as well. So some people feel like USB is not a very good transport, or maybe they have a DAC that doesn't have a USB input, and so they want to have some other options. A digital converter, a DDC, unlike a DAC, takes typically a USB digital signal in, and then it outputs any number of digital audio formats from I2S to SPDIF to AES-EBU or whatever your format is that you care about. This particular example also, it looks like it has a 10 megahertz clock in, and we can talk about the pros and cons of those later on as well. So essentially, before streaming, we had a CD transport connected to an external DAC, and now you have a streaming transport that's connected to an external DAC. But architecturally, it's all pretty much the same. To get started with streaming, you need a DAC. And a lot of people have a DAC already that they like. An external DAC already that they like. If you don't, you can buy what's called a streaming DAC. A streaming DAC has network in, so it's kind of like that little Raspberry Pi. If you look on the right-hand side of this device, but then on the left-hand side, it has kind of DAC-looking connections on it. So network in and some forms of digital audio out is what we call a streaming transport. And for all these devices, you can, again, define them by what their inputs and outputs are. You can kind of figure out what kind of thing they are. This is an example of an Eversolo product, but you can see it has gigabit networking in. It does have some digital output, so it does the D to D, DDC type of functionality, but also has analog outputs. So can be either used as a streaming transport or a streaming DAC. And then another example that's even more complex has speaker outputs. So in this case, this is what we call a streaming amplifier. And you can even find streaming loudspeakers. So KEF has a few of these things, and other folks do, where it's network in and, uh, audio air pressure changes coming out of them. So you can have a streaming transport, a streaming DAC, a streaming amp, streaming headphones amp, or streaming speakers. What we're doing here when we combine these features together is you don't have to have a whole bunch of separate boxes. So instead of having a streaming transport and a separate DAC and a separate amplifier and separate loudspeakers, you can combine some things together. But as we find for traditional audio components, oftentimes separates are better. It just kind of depends on your use case. If you want to get the best performance, at least maybe I'm old-fashioned, but if I want to get the best performance, I generally prefer separates so that I get to choose, for example, what power amplifier matches up to my loudspeakers best. I don't want to buy a generic streaming amp because that amp may not have contemplated the impedance characteristics of my speakers or my room or their efficiency or anything else. So I want to buy a separate amplifier that matches my speakers well. And then I usually want to buy a preamp that drives that amplifier well. And has the right inputs and configuration that I need for whatever else I might be doing. Maybe I need a preamp that has a home theater bypass so that I can connect my home theater processor to it and switch between 2-channel music mode and movie mode, for example. So not only from a functionality perspective, but oftentimes from a performance perspective, you get more by buying separates than you do by integrating things. But maybe you're building a second system or a system for your spouse or your children. You don't want to have a whole rack full of components. Buying a device that's a streaming amp that has everything in it, you just have to add loudspeakers, can be beneficial and save some time. All right, I want to talk a little bit about, I think some of you have probably seen this diagram before because I used it 5 years ago when I did my initial talk for the San Francisco club. But the essential components for high fidelity streaming in the house really are, you can see this giant network thing in the middle of this diagram. That's kind of the most important part. And the reason it's important is because unlike streaming Netflix, with streaming Netflix, you have maybe your Android TV box or your smart TV that's connected to your home network, and it can talk to the internet and download content. And that traffic is what we call north-south traffic. It's going to the internet and back down to a single device. And north-south traffic is the easiest kind of communications that you can have on your home network. Unfortunately, for high-fidelity streaming, in order to get the full capability, we need also east-west traffic. We need network traffic to be able to travel from one device on your network to another device on your network. And that is, for a lot of people's networks, that's hard. And the reason that that's hard, I blame the rise of what we'll call Wi-Fi mesh type network topologies. And here's how this happens. So let's suppose you get internet to your house. You have maybe you've got fiber networking coming into your house from your ISP. They set up with this little obelisk that has maybe a few switch ports on the back, and it's got built-in Wi-Fi, and it's also a router, and they put it either in your living room or they put it in your closet or wherever it goes, and now your house is networked. Maybe it takes them a couple hours to set it up. They ask you what you want your Wi-Fi network name and password to be, and then they hand this device off to you, and you're networked now. But maybe you have a big house, and you discover after they leave that the Wi-Fi signal is not so great in your den or in your basement or in your attic or someplace else. So you talk to your nephew or a friend, or you do a little bit of research, or you talk to ChatGPT or Google Gemini or whatever, and what they recommend is that you get a Wi-Fi mesh system so that you can extend the network to the rest of your house. So you go and buy an Arrow or a TP-Link, a Deco, or any one of these Wi-Fi mesh devices, it typically comes with 3 little cylinder-looking things or 3 little boxes or pods, and you connect one of them to that thing that your ISP left, and then you put the other ones other places in the house, and they all kind of connect together. And then it asks you when you set it up to enter your network name and password. And so you grab the little yellow sticky that your ISP left behind you and type in the network name and password that they put on that yellow sticky, and you have your network up. And of course, everything on your network can work. It can talk to Netflix. You can stream from Spotify, and everything is good. But then you try to print something and you discover that your laptop cannot talk to your printer because what you've done by setting up this mesh network is you've created 2 different networks in your house, possibly unknowingly, but you've created 2 networks that are firewalled or at least half firewalled off from each other. And so you talk to your printer manufacturer and say, hey, my printer was working just fine before I got all this, before I got fiber, and now it's not working anymore. But before I added my network, and they'll tell you, well, we've got this cloud print functionality, so you can print. You just have to set up your printer to support cloud printing, and then you can print to your printer that way. And so that's what people do. And I think this is why cloud printing became a thing, because people have broken networks that don't allow east-west traffic. So the way cloud printing works is your printer connects up to the manufacturer's little proxy on the internet, and then you connect up to that same proxy, and that proxy allows your printout to kind of travel east-west on the manufacturer's network instead of on your network. So you print up, you print up to the internet, and then your printout comes back down onto your printer that way. So printing only using north-south instead of east-west traffic. And that's how you kind of get around that. Unfortunately, for streaming audio, currently there is no such a thing as that. And so you have to have a network that's not broken. You have to have a network that allows every device on your network, at least that's associated with audio, to talk to every other device. And so I'm going to talk a little bit later on about how we put that together, but let me just run through kind of these essentials. Mesh versus network access point, which is better. So I think I want to talk a little bit about that as well. So the ideal, I'll just jump to the chase, is that the ideal topology to keep things as simple as possible would be to take that ISP obelisk thing that they gave you and connect one giant switch to it. Maybe, I don't know how many switch ports you might need in your house. Maybe you need 24, maybe you need 48, however many Ethernet drops you can get run throughout your house. Let's say it's 24. That's a pretty good size. You connect that, this big unmanaged 24-port switch to your ISP, and then you connect everything else that you possibly can to this big switch, or at least everything that's audio related to this big switch. And that would include also access points. So an access point is kind of like the these all-in-one router / Wi-Fi devices, except the only thing it does is connect Wi-Fi devices to your network. It doesn't actually have a router. It doesn't assign IP addresses. It doesn't do anything else. It's just, all it does is convert sort of radio frequency connections to network connections. It behaves kind of like a switch as far as topology goes, or like a wireless bridge, but it allows multiple devices to connect. The devices can talk to each other within the kind of small network that's inside the access point, but then the access point typically has a cabled or a wired connection that runs back to this one big switch. And so if you do that, you're not segregating your network. Everything is on the same broadcast domain. Everything's on the same logical network. Everything will have network addresses that are assigned from the same DHCP server. And so everything will be able to talk to everything else. So access points are a kind of a clean way to do that. Wi-Fi mesh networks, unfortunately, do create separate segregated networks. And I'll talk a little bit later on about how to make Wi-Fi mesh networks work also, because I know some people either have them and can't get rid of them or don't want to get rid of them. But I will say that they do add some complexity to your troubleshooting, which is not so fun. So we talked a little bit about Wi-Fi versus wired. Usually you want to have your music server connected over a wired connection, because it may be streaming music to multiple devices throughout your house, not just one. We have in-ceiling speakers throughout our house that are connected using streaming amplifiers. And so I can stream to all the speakers at once if I want to, either the same music or different music. And it all works beautifully. And if I didn't have the music server connected via robust wired connection, then it may struggle to keep up with the bandwidth demands for those things. All right. And then output devices would be, again, these streamers. So streaming transport, streaming DAC, streaming speakers, anything that can take a music signal over the network and play it out to whatever room you're in. And then typically your remote controls will be your smartphones, tablets, laptop computers, anything that you can use to play, pause, skip besides like an IR remote control, anything that's a network connected remote control. Those things are typically done over Wi-Fi. They don't have to be, but it's inconvenient to walk around your house with a tablet that's tethered to a network jack. So typically those are Wi-Fi, and those are fine for that. The main point on how to make any streaming environment sound as good as it possibly can is to offload as much processing as we can from your streaming device. I don't know. I would say this is probably the most critical point of the whole talk today. If you have, for example, a Wii Ultra as your streaming device, they have, as I showed in that little diagram, a tiny computer that's inside of them. And the manufacturer will have taken certain steps to isolate the demands of that computer, electrical demands of that computer, from and its power supply from any of the other components that are in that device, so that there's no contamination. They might put it inside of a little copper Faraday cage, this little computer, so that it's the noises and radio frequencies that it generates when it's thinking hard don't impact any of the circuitry around it. And they should isolate these things. And better solutions will have completely independent power supplies for this little computer versus all the other circuitry that are in the device. But those things are expensive, and they're not always done particularly well. And we have this thing in science called the inverse square law that says if we have one device that emits radio frequency or other kinds of airborne contamination, not airborne, but any kind of contamination that can be picked up either electromagnetically or magnetically. If we have a device that's emitting these disturbances and another device that's sensitive to them, if we place them twice as far apart as they were formerly, then the receiving component only receives a quarter as much of the interference. And so separating these devices by I found 2 or 3 feet is usually adequate to eliminate the contamination, and then having them on separate power supplies that are isolated obviously prevents power supply contamination. So we want the processing of the audio and the processing of the streaming to happen someplace other than the tiny computer that is feeding our DAC. And we want that tiny computer to be placed at least a couple of feet away from the DAC itself. And if we do those things, they're kind of structural things, but you get them for free if you just arrange things properly. Then you can significantly improve the sound quality of just about any streaming solution. Again, like folks like Render, and their products that are upwards of $20,000, they've gone through heroic efforts to separate and prevent any contamination from the computer sides of their devices to the DAC or the streaming sides of their devices. Not everybody has been that careful, and I would argue again that if you can just separate the devices and separate the processing, you'll get better results. So how do we separate the processing from our streaming process, our streaming solution? If you buy like a standalone streamer, like a Wii Ultra, I'll use that as an example since it's pretty popular these days. When you log into it and get it all set up, you're going to put in your Qobuz or your title credentials, and you're going to have it play out over one of its several outputs to either through its analog outputs, so an internal DAC, or through USB to an external DAC. Either way, it's doing a lot of work behind the scenes. So after you put in your Qobuz credentials, it's going to make a connection to Qobuz in the cloud over the internet. And that encryption, that connection's encrypted. It's encrypted to protect your login credentials from being exposed, and then also you're going to maintain a persistent connection, and it's going to download the compressed music over a encrypted connection. So it's having to receive the frames of music from the streaming provider, decrypt each one of those, and then because they are compressed in a FLAC stream, it has to uncompress the FLAC to PCM samples. It's got to separate out the metadata so that it can send the album art to its display, and the music, the actual PCM samples, it can route those to the internal or the external DAC. So it's doing a fair bit of processing. And we'll touch on this a little bit later, but there are Connect technologies like Tidal Connect or Qobuz Connect or Spotify Connect that have the endpoint even doing a little bit more work besides all of that stuff. And it still has to respond to commands from your control devices. So your play, pause, skip, or you want to adjust volume or adjust PEQ, all those things. It's constantly having to listen to any of your remote devices that are talking to it. We want to get the best sound out of these streaming devices. What we want to do is take all of that processing and put it someplace else. Have that processing happening on a dedicated computer that's someplace else in your network, that's not in your listening room, that's not anywhere near your DAC. It can have fans that turn on. We don't care. If you can put that computer someplace in a closet or in I've got mine in a closet under our stairs, under the landing of our stairs, or in a laundry room, or even in an office where you don't normally listen to music. Let that computer do all of its processing someplace far away from your listening room, and then have the endpoint in your device dirt simple. It doesn't handle any compression or decompression. It doesn't handle any encryption or de-encryption. It doesn't handle any requests from a remote control device or display. Have to reflect a display of its album art. It could have a little album art display on the front of it, I suppose. That's not so bad, but we want the little tiny computer that's inside of that streaming device to be as idle as possible. And I know some people are going to think I'm crazy, but I'm pretty convinced that I can hear a difference for a lot of these devices if that processing is offloaded versus if that processing is happening locally on the streamer. So what have we talked about so far? We talked about simplifying your network by flattening it. I'm going to go into a little bit more detail there. So you want to have, if you can, at least for your audio connected devices, everything just on a single unmanaged switch, Ethernet switch. And those are pretty inexpensive. You can buy a nice quality one for less than $100. And if you have, for Wi-Fi, ideally you'd like those Wi-Fi access points plugged into that switch. If you have I need a slide for this, but just bear with me. If you have a mesh type of configuration, you could do sort of the same things. You could, your mesh network is going to have like these little pod things everywhere, but to one of those pods, ideally it would be the one that's connected to your router, but that may not be possible. You want to connect one big switch that you connect all of your audio devices to. So just pretend like you don't have a Wi-Fi mesh network, and connect all of your audio devices to a switch, and then have that switch wired to one of the pods or one of the mesh nodes. And that'll help you kind of get closer to this. The other thing that I would recommend, since I'm giving these recommendations, is to turn off, if you can, the Wi-Fi in your ISP's little obelisk box that they gave you. If you're using a mesh system, you don't need both Wi-Fis on at the same time. You can turn off your ISP's one. You should be able to log into your ISP equipment and or maybe make a service call and ask them if they can turn off the Wi-Fi that's inside of that box, so that you don't have multiple Wi-Fi networks that are competing with each other. Another thing that I found that I was pretty surprised about, I installed a little Wi-Fi analyzer on my phone, and I walked around the house and discovered there was a really strong Wi-Fi signal coming from one of our offices. And I took a closer look, and it was this HP Jet Direct connection from our printer. So our printer came with a really strong Wi-Fi kind of radio built into it that will allow you to print to it directly from a mobile device by having that mobile device join the printer's Wi-Fi network. But when you're not using that, we never use that, never at all, it's generating a lot of Wi-Fi interference that was reducing the range and capability of the Wi-Fi network that we had in our house. So I logged into the printer and turned off that Jet Direct thing. The only Wi-Fi that you want to have in your house is the Wi-Fi that that all of your devices depend on. Let's see. How about getting rid of your ISP equipment and buying a simple cable modem? Yeah. um, that's effectively what I have done. Is I am using my ISP's optical network terminal, or ONT. It's a device that comes into your house from the street. It's got a fiber network cable plugged into it. It does require power, and then it has an Ethernet port. So I get an Ethernet handoff out of this ISP's device, and that goes directly into my router. I don't use the router that the ISP provided me at all. Some ISPs will let you do that kind of stuff. Other ones, I think AT&T Fiber require that you keep their router in, but you could set it up in something called pass-through mode so that it basically kind of doesn't create any problems, and it just basically acts like a done device. It doesn't do any firewall capability. That's on you to have a firewall in front of it. All right, let's run through a couple of these things. So these are different streaming architectures, and I want to zero back in on the architecture that I found to be the most reliable. There's integrated, so basically everything's in the listening room. This is the way our render used to work. Our render is now supports third-party devices like Roon streaming to it, which is kind of cool. There's distributed and mesh. Mesh is kind of like Sonos or Denenhios. You have point-to-point where you've got a player and a renderer. So if you've used Bubble UPnP or mConnect or Apple AirPlay, they're kind of like that. And then there's Spotify Connect, there's Tidal Connect, we have Cobas Connect right now. Like I said, the Connect ones end up using a lot of CPU resources based on my measurements. So I've literally logged into devices that support these Connect technologies and turned them on and off and tried different ways of streaming to them. And the Connect technologies can use up to 25% of the CPU resources in these devices. And we want them to be as close as we can, like 95 to 99% idle. We don't want the CPU to be so busy. So the Connect technology, if your goal is sound quality, is not really where you want to be. Point to point has some pretty significant limitations that I'm not going to talk about here. So you'll just have to trust me. Mesh technologies as well. There's no central server, so there's no place to offload the processing to. So each endpoint has to be responsible for converting audio formats depending on what the capabilities are of the locally attached device. And so they're not going to be best for sound quality either. And then integrated, everything in the listening room doesn't allow us to physically separate the computationally busy and the physically or electrically or electromechanically noisy pieces from everything else. So we like to have is a distributed solution where we do the processing someplace that's far away from the listening room, and then have endpoints that are bespoke, purpose-built devices for streaming audio that do very, very little processing. All that we want them to do is copy the audio, uncompressed, unencrypted audio from their network connection to either an internal DAC or locally connected DAC. Let's see. I think, can I rank the methods? Alan, rank what methods? Connection methods. Yeah, so I mean, if you're asking me to rank like digital connection methods, so this would be connecting an external DAC to a streamer. I've tried a bunch of different ones, and it kind of depends on the DAC. I've got, I don't know, maybe a dozen or so DACs of various vintages and qualities, and then almost as many streaming transports or devices that are capable of doing that kind of thing. And it really depends. There are some DACs that do extremely well over USB, and then some DACs that, in theory, their USB should be the best. You get the broadest range of formats. You can support up to 32-bit 768 kilohertz. Not nobody ever records in that, or DSD 512. I've only got one album that I bought in DSD 512 of the 3000 that I have. So that's not that useful. But sometimes with certain DACs, the USB just doesn't sound as good as more traditional coax or even Toslink SPDIF connection. And I've got one DAC that I'm using right now over an AES EBU connection that I've convinced myself sounds the best. So you kind of have to experiment. I haven't figured out a reliable way of determining. I know Shit Audio has their Unison 5 or Unison 6 or whatever it is USB connection, and so they're fairly convinced that that is the best connection for their DACs. But in a lot of cases, you'd expect USB to be the best, and it just isn't for whatever reason. I2S is a weird one, and I'll explain why as best I can in my layperson understanding. So it used to be that for any SPDIF connection, whether it's Toslink or AES EBU or BNC or any of the different SPDIF style connections, it used to be that the transport was responsible for delivering the clock signal to the DAC, and that clock signal is kind of multiplexed or mixed in with the audio data, and then the DAC's responsible for recovering that clock. But the DAC generally, in early days, used that clock signal to actually drive the clock chip in the DAC, and this is why we found jitter to be such an awful problem. DACs that are popular from AKM or everybody hearing me okay? Or other manufacturers, they don't use the clock signal that comes into them. They might detect the clock signal and they'll use a PLL so that they can follow the clock signal and not get too far off of it. But they have a clock that's typically either on the DAC chip or right next to it, and the DAC chip doesn't, like I said, it uses a PLL or a phase locked loop in order to kind of roughly follow and not get too far behind or ahead of the transport. But it doesn't rely on that clock signal from the transport to drive the DAC. And so modern DACs are generally completely immune to jitter because I guess if it's so bad, then you'll have dropouts in the signal. But otherwise, they're not using the clock signal that's coming into them. I2S is a little bit different because the clock signal arrives into the DAC via some dedicated pins and lines that are on the I2S connection. The DAC is, I guess, in most implementations, obligated to follow the signal that's coming from the transport, and so you can actually end up with some significant jitter problems over an I2S connection that you wouldn't experience necessarily over an SPDIF or a USB connection, which is kind of interesting. People say that they hear a difference in I2S connection, and I don't doubt that they do, but it's probably objectively worse than other connection styles just because of limitations in the reliability of the clock. The I2S connection style was intended to be like a chip-to-chip kind of communication style, not going over like a several foot long HDMI cable or HDMI style cable. And so I think that is why people hear greater differences there. And maybe they hear more detail, but what they're actually hearing is jitter that's creating harsh high frequencies that weren't present in the original signal. Hard to say. So I talked about how we talked about different connection styles and how for a given DAC, I think you just kind of have to experiment. And that's why DDC or digital converters are kind of fun tools or toys to have in your toolbox, because maybe your DAC supports USB, ACBU, and I2S, and a bunch of different SPDIF type style connections, but you only ever tried USB. If you get a D-to-D converter or a DDC, you could use that to try some of the other connection styles and see if you can figure out which one you prefer without having to buy another transport that happens to have those connections. So I don't know that I would have a DDC in my system permanently, but I find them to be useful tools for kind of helping me figure out what connection style works best for a given product. So computer audio for streaming, we want to keep fan noise, spinning hard drives, which hopefully nobody has anymore, but sometimes older NASs will have those. We don't want any hard drives in your listening room. You don't want things that can create ground plane contamination. Switching power supplies are a topic. People have concerns about those. I have found that they are, if they're purpose-built switching power supplies for audio, I haven't noticed problems with them. I will admit that I haven't bought one of the devices that lets me take measurements. I have played around with I can't remember what it's called, but a number of different products that you can plug into a power outlet to kind of reduce the impact of switching power supplies on other circuits that are nearby. And I think it's, I think if we'll talk about these tweaks later on, but I think if you discover that you have a problem that one of these tweaks solves, then they can be beneficial. If you don't have the problem and you use the tweak anyway, I guess at worst, you risk wasting a little bit of money. Typically, you're not doing anything that's harmful. So you just kind of have to experiment with those things as well. Like I said before, a noisy busy is a CPU or a busy CPU is a noisy CPU. So if we have a computer that's close to our audio components, we want it to be as idle as possible, ideally completely idle. If we can have it doing just the bare minimum amount of work possible, we're going to have better sound. So I would say if you have a streamer that has fancy view meters that'll bounce back and forth on the screen and provides other types of entertainments like that, you should feel, I don't want you to feel nervous, but like you should recognize that you might be making some trade-offs in visual appeal and sound quality. You may not be getting all the sound quality you possibly could get out of that device by turning on features like that. So anytime you're asking your endpoint device to do extra processing, just be aware that that extra processing will probably come at some small cost to sound quality. Whether it's enough to be audible or measurable or both really depends on the device and your own experience. But your antennas should perk up, and mine certainly do if you see a configuration in your system that is relying a lot on local processing. What's the problem with the spinning hard drive? So spinning hard drives, they create mechanical vibrations. Sometimes there's enough noise coming from them, you can hear them from the listening position if your room is quiet. I think that's the main thing. They probably also, if they're using the same power supply, maybe like it's a USB powered spinning drive, if they're using the same power supply as the device to which they're connected, they can cause power dips in that device. So for example, if an Eversolo DMP6 is actually driving the spinning hard drive, its power supply may receive higher and lower amounts of demand depending on what that hard drive is doing, and that could impact the sound quality of the device. So it's best if you can put those spinning hard drives someplace else. I mean, I have a lot of spinning hard drives. I have a NAS that has 13 of them. But it's not in my listening room. It's under the stairs at a place where nobody can hear it. For SSDs or solid state devices use much less power, and they don't produce any mechanical vibrations. So they aren't as harmful. I don't think I would want my streaming device also accessing files on a local storage device if I could avoid it. Because again, that's additional processing besides just playing back music. You're asking it to manage a file system and keep its memory buffers full from data that it's reading off of a storage device. It's probably pretty minimal, but if you could, you'd want to put that storage someplace else as well. I doubt that it makes an audible difference. This is another one of those maybe I'm neurotic kind of things, but I would want to avoid having any kind of storage device in the listening room. If I could easily avoid it, I would do it. But it's a solid state device is not going to make any noise, so unless it's very badly broken. So I wouldn't sweat about that one the same way that I would about a spinning hard drive. Oh yeah, so this is an interesting one. We talk about USB cables that carry both the data signal, and then they also have a 5-volt power signal. And conventional wisdom I always thought was audio manufacturers that make these cables like to separate the data lines from the power lines in these USB cables. And I always thought it was because you didn't want the data or the audio to be contaminated by the power signal. I found out later on the reverse is the problem. The audio signal will induce, it's a kind of a square wave, noisy, high frequency signal. It will induce current and put noise into the DC power that otherwise might have been cleaner. And so it's actually the audio signal that is corrupting the DC power. And that DC power does go into the DAC, and then it's up to the DAC's regulators to kind of quieten that part down. Usually most DACs have a USB receiver chip in them, and although the DAC's internally powered, the receiver chip very often will get its power from whatever device is connected to it, from the transport. And so if that DC power is super noisy, it has to work harder to regulate that power. And so, it makes a little bit of sense, and I think that's why USB cables for audio use kind of turned up instead of just people using printer cables. It's been a while since I've tested with a modern DAC, so I don't know if my fancy $300 USB cable now outperforms a printer cable, a good quality printer cable for when I'm using a brand new modern DAC. But it used to be the case that made a little bit of difference. And then, like I say, inside of a DAC, the A still stands for analog, and so we still need clean, stable power. If you think that you have a power problem, it's appropriate to investigate and deploy solutions to clean that up. If you touch your finger on top of your DAC, and the sound gets quieter, maybe you heard a hum, and if you lift your finger up, the hum returns, and if you put your finger on the DAC, the hum goes away. You have a grounding problem that you should look into. If you can touch all of your components and no hum gets louder or quieter, then you may not have a grounding problem, and grounding solutions, you could still implement them, but they may not have as much benefit. So most data transfer, if we're just trying to move data around, forget about audio for just a second. Most data transfer is it's bit perfect. There's no generation loss. So I can copy my tax return to a thumb drive, and then I can read that file off of that thumb drive and copy it to another one. I can do that 100 times if I want to. I don't really want 101 copies of my tax return, but if for some reason I wanted to do that experiment with any data, I can do that. And even though it's a copy of a copy of a copy of a copy, at the end of that 100th copy, if I compare the two, they'll be exactly the same. I'll get the same refund from the first thumb drive or the original copy as from the 100th copy. And you can do these kind of copies over your home network, or you can do them over a public network. You could email yourself a document, and then once you get that email back, you could email it again, and you can do that 100 times, and you'll get the same information. We just take that for granted. It didn't used to be the case. We had modems and all kinds of problems before, but networking now is and copying data around from storage device to storage device, or between storage devices and networking, it's completely reliable. We just take it for granted. For computer audio, some data transfer is not really guaranteed to be bit perfect. So we may have error detection, but the transfer itself may not be bit perfect. USB protocols use something called an isosynchronous mode. I think I'm pronouncing that right. For moving the data across a USB bus. This is different from mass storage, where you're connecting a thumb drive or a hard drive, where the data is going to be copied in more of a block mode, and it's going to be copied perfectly 100% of the time. When we're streaming audio over USB knows that it's an audio signal, and it treats it a little bit differently. The drivers do. And because we don't want to have gaps or dropouts like you heard a little while ago, what's the refund? You will, because we don't want to have gaps, what the USB protocols that people design for USB audio were determined to have, basically the show must go on. If there's any problems, we'll flag these frames as errors, or maybe we do some error detection. We'll flag a frame as error if it's got a problem, but we're not going to request the transport to send us that packet or that frame because it was corrupted. We're just going to send that frame to the DAC with a little flag that's set on it that says, hey, DAC, by the way, this frame's corrupted, so you can interpolate between samples, you can mute, whatever, you can handle it however you want to. Just be aware that this is corrupted. And that's actually how USB audio works. And this is why people rightly say maybe USB is not the best. Gordon Rankin and other people have done a bunch of research and found that in real time there are, in fact, when you're playing audio over USB, you will get these kinds of errors. Sometimes they're caused by, if you have less than ideal cables, they're caused by reflections that are inside the cable that are caused by impedance mismatches on one side versus the other. The USB spec for USB cables requires a 90 ohm impedance for the whole cable. It's 45 ohms on one side and the 45 ohms on the other, and they have to be matched within a reasonably tight tolerance. And if they're not, you can end up with reflections that end up causing corruption every once in a while. And you know, our USB audio devices don't have a little light on there that, or a little counter that says how many times they've detected bad frames. So we don't know if it's happening once per album or 1,000 times per album. But if you think of it, it's the same thing like when we were playing CDs a long time ago. We had this Reed-Solomon error correction and other kinds of technology to allow you to play your CD even if it had a minor scratch or some dirt on it. It would still play without skipping. If it was badly scratched, of course, it would skip a lot and make a bunch of that noises, right? But I always wish that we had CD players that had a little counter on the front, a little digital counter that said, hey, you know, by the way, in playing this CD, I found 25 errors that you might want to be concerned about. There are tweaks that are, you know, exist for solving problems like I talked about. Galvanic isolation is a big one that people talk about. And it certainly makes sense for certain styles of connections like coax SPDIF or USB, where you could potentially be creating a ground-to-ground connection or even chassis ground to chassis ground connection between two different components, which may or may not have their own single path to ground. I'll give you a typical example. A lot of Raspberry Pis or streamers, they'll have a wall wart power supply that has just two prongs, no ground plug, and that will connect to the transport device. And then you'll have a USB cable coming out of that into an external DAC, and that external DAC will have a three prong plug that has a ground connection. And so the streamer and the DAC are sharing the same ground connection, but that you could have potentially some ground current that's flowing from the streamer into the DAC in order to get to ground. And I've actually taken a voltmeter and measured some of these things, and I've measured a difference in chassis ground between components of up to like a couple or 3 volts, if they don't have independent grounds. And so that's you know, that can be a potential problem. So a lot of people say, well, we'll solve grounding on the network side of things by using fiber optics instead of Ethernet cables. Ethernet cables, you can take a look at them. They have little copper wires in them. There's 8 little copper wires on each side. And that can't possibly be good. That could create all kinds of grounding problems. But what a lot of people don't realize is that per IEEE spec and international specifications, every single switch port is, if it's compliant, is required to be magnetically coupled. And so so that you can think of it as like a couple of transformers that are passing the data across rather than a direct electrical connection. And the reason they were required to be magnetically coupled is, if you think about it, in early days, especially, it's more common in our homes now, but it used to be like in businesses, and it's still the case. You have, you know, 50 yards or close to 100 yards of networking cable connecting devices all over the floor of a building. And then you'll have cables that are running between floors to connect those together as well. And these are typically all copper connections. And all of the endpoint devices that these connections are plugged into are on different outlets and probably different power circuits with different grounds. And if all of this stuff was connected electrically via copper, you'd have all kinds of problems with hum and you know, ground currents flowing between these devices, and it would be a disaster. So the Ethernet guys made the spec so that the switch ports have to be magnetically coupled. They can't allow ground current to flow through an Ethernet cable. If you use shielded networking cables, you partially kind of get away from that. I'm not going to cover the details a lot here, but what I do tell people all the time is that unshielded twisted pair is your friend. You don't need or want shielded cables in your house. They will are much more likely to create problems for you rather than give you solutions to problems. So unshielded twisted pair and magnetically coupled switch ports mean that you get galvanic isolation for free in your home network. Fiber optic media converters are really popular, like I say, for a lot of people are messing around with those for audio use. There are even some streamers now that are coming with SFP ports built into the back of them so that you can connect them up over an optical connection, because there's some perception that optical connections offer more purity or whatever. And I would say there's just not any evidence that that's the case. And the other thing I'll say is that a media converter is converting light back to copper inside of the device. You're not getting away from copper. In fact, you're having to have these media converters on both ends of the connection now, and those are things that can go wrong. So you've kind of doubled the surface area of your troubleshooting by adding these kinds of things. Now, there are legitimate cases for using fiber. The principal one is if you have to move a lot of data over a long distance. So, for example, if you have a large property and you've got a separate media shed that is 500 yards or half a mile away from your primary house, and you want that to be networked as well, you can have a trench dug and underground conduit with fiber networking run through there, and you can connect your outbuilding that has your audio equipment to the main house and have all the connections handled. With copper networking, depending on what speed you're trying to achieve, you're limited in cable length run to 100 meters, maybe sometimes a little bit less if you're trying to do 10 gig and you don't have the right kind of cabling. So there's a length limit, but 100 meters is pretty long for a single connection. So unless you're Bill Gates or somebody who has a massive house, you probably don't have a lot of runs or a reason to have a run that's longer than 100 meters, a single run that's longer than 100 meters. I understand that you could have two devices that are 200 meters apart with a switch in between them, and that ends up being a pretty massive house. So it's I won't say it's impossible that somebody in a domestic environment would have a valid use for fiber optic media converters, but I would say it's unlikely that there's a reason that would be truly beneficial. There's a big topic about audiophile networking, where you've got these manufacturers that are buying maybe off-the-shelf Ethernet switches from Netgear or TP-Link or whatever else, and then they're adding a bunch of capacitors and filters and other circuitry, or maybe they're even building a bespoke 8-port switch for $1,000 that makes the audio sound better. I will admit that I don't have experience with this, but I also, from what I understand about data transfer, I don't see how they're solving a problem that exists for most of us. If you happen to have the problem that they're solving, like I say, you could give it a try and see. But I will also say that it's easy when you buy something to hear things that maybe are not really there. And if that effect is short-lived, you'll know that you don't have the problem that it solves. If the effect, placebo or otherwise, remains in effect after some weeks, by all means, keep the device if it's worth what you paid for it. But just be aware that our human minds can play tricks on us. Any advantage to go using gigabit versus 100 megabit? I've got a bunch of Weem amps, 7 of them actually, that I'm using for streaming audio throughout our house. And I was surprised to find that they're just 100 megabit. But it turns out that 100 megabit is massive overkill for pretty much all audio formats, at least 2-channel audio formats that we use in the house. So I would say gigabit Ethernet is kind of the standard for domestic use right now. You can buy gigabit switches for less than $20. A lot of people are kind of messing around with 2.5 gig or 10 gig for certain applications like Photoshop and video editing and stuff like that. But I would say you almost have to go out of your way to buy networking equipment that is less than gigabit. So I would encourage folks, if you're building out your network, to standardize on gigabit, and then if you have devices like the Weem amps that are only 100 megabit, the networking equipment will automatically speed adjust and negotiate to support those slower devices. Yeah. Linear power supplies are a topic. I have some limited experience with linear power supplies, but I haven't found a situation where, um, except when it's really cold in the winter and I needed an additional heat source in the room, I haven't found a case where I thought the linear power supply was adding something to my room. Your experience might be different. Vibration dampening is a thing as well. I think, well, just for good audio hygiene, right? We don't want our equipment, even if it's solid state, we don't want it bouncing around. If your ether region is 100 megabits, there's a theory that 100 megabits is advantageous for audio because, and I'll explain this in a little bit more detail, but essentially for streaming audio, we want a nice steady stream. We don't want like a burst of traffic. My hand went right off the screen. We don't want a giant burst of traffic and then silence and then another giant burst of traffic. We'd like to have the audio kind of stream over the network in a nice, steady, smooth rate. And the reason we want to do that is because these giant bursts in traffic mean that the buffer on our endpoint device fills up super fast, and then there's a burst of processing that has to take place to empty that buffer. And so if you have these like spikes that are happening every 10 times a second or whatever, then your processor is going to be busy, for those short durations or bursts of time, and then it'll be idle the rest of the time. We'd like the processor just to stay idle the entire time. And so there's a theory that slower networking speeds like 100 megabits or maybe even 10 megabits for some applications could smooth out the data transfer from our server to our endpoints and therefore make their CPU behavior a little bit less bursty. I like that idea, actually. I have no way to test it and see, but it sounds reasonable to me, and it's consistent with my thinking about trying to keep these endpoint devices as idle as possible. Keep in mind, though, that even 100 megabits per second is like, I might need to do the math, 70 times faster than the speed we need to transfer Redbook CD audio, which is most of what we're playing. And so the traffic is the network traffic is still going to be potentially kind of bursty, right? Because our link speed is more than 50 times faster than we need it to be for the data we're sending. So is there a difference between 100 megabits and a gigabit in terms of calming the traffic over the network? I'm not really sure. If you could go down to 10 megabits, I could kind of see the argument. But 100 megabits is not going to hurt you for what we're trying to do. I think even over, if you're doing DSD 512 or 32-bit 768 kilohertz, you're still only using about 48 or 50 megabits per second for two-channel audio. And so 100 megabits is plenty of bandwidth for your endpoint devices. Obviously, for your streamer, you're going to need, or your server, you're going to need more throughput than that. I don't know why manufacturers don't focus on vibration control. I think it's important for audio hygiene. Different sampling rates and formats affect the reconstruction filters in the DAC and can influence the pre-ringing and post-ringing. And so, when we started down the path of higher than CD resolution audio almost 2 decades ago, I was really fascinated by it because it definitely made a difference. I could take a CD and then sort of upsample it to 88.2 kilohertz, 24 bits, or 176.4 kilohertz and 24 bits or whatever. And even though it was the same data, all I'd done is just increase the sampling rate by having my digital audio software or workstation software or whatever I used interpolate and add a few more little samples there. But it did seem to make things sound better. And I was very curious about that. And from taking some measurements of the analog output of various DACs at different sampling rates, what I've discovered is that when you upsample or when you change the sampling rate, even if you don't change anything else about the music data, it changes the reconstruction filter's behavior and its impact on the analog waveform. And so you can end up with like compared to these two, you can see there's shorter pre and post ringing, and there's less of it. And different DACs these days, chip DACs tend to have different filter selections as well, so you can kind of choose different options. But sometimes, you'll have a DAC that really, really sounds great with DSD, but it doesn't sound so great for PCM. Or you'll have a DAC that sounds great at 96 kilohertz, but maybe not as good at 88.2 kilohertz or whatever. The Benchmark guys had done some research on this, and they determined that for their DAC or their DAC 2 product, that it sounded best at 110 kilohertz is the sampling rate that they needed to feed it. And so they have a chip in front of it. I might be wrong on the sampling rate, but you get the idea. So they had a chip in front of it that basically takes all of the input signal and resamples it to the rate that the DAC likes the best and that the filters in the DAC work the best on. And that's just what the DAC gets. This is kind of the idea behind HQ Player and other tools that people are using, even Roon as well. If you can figure out what sampling rate your DAC works the best at, or whether it sounds better with DSD or with PCM at different rates, you can resample everything on the server that's in your closet someplace far away to the format that the DAC likes the best, and then get the best results for everything. Most of our music that we're going to play is going to be Redbook CD format. Even, if you have any kind of consequential library at all, it's almost certainly mostly 20 or 16-bit 44.1 kilohertz. But if that happens to be the worst performing input for your DAC, you'd be kind of stuck if you were in a CD world, but you're not anymore. DCS makes an external device. Chord famously has a device that resamples things to crazy levels. I think PS Audio internally upsamples everything to DSD. And so it's a reasonable approach. But if you don't want to spend Chord money or even PS Audio money or certainly DCS money on a DAC, if you have a server that can handle these tasks for you, you can figure out what sampling rate sounds best with your DAC, and you can do it basically for free instead of spending 5 figures for a DAC that will probably be obsolete in a few years anyway, because they'll come out with something better. You can solve the problem in software, and again, take a distributed approach, a component-wise approach, to, I would argue, get pretty similar results. I'm not going to say that you can buy a $200 chip DAC and turn on upsampling in Roon and get exactly the same performance as a Chord Dave or whatever the fancy thing is that DCS is making these days. But I am saying that you can probably get a larger percentage of that performance than people who did spend the money would be willing to admit. Best practices for computer audio streaming. Like I say, keep the server and storage away from your listening room if you possibly can. A separate streamer and DAC, separate the streamer and DAC by at least 15 inches. I've expanded that to 2 or 3 feet now since I put this slide together a little while ago. I think a little bit more distance is not a bad thing. Use wired connections instead of Wi-Fi for streamers and the server, so that you don't have audio glitches like you had experienced with me during this talk. Avoid the Connect apps because those require more local processing on your streamers. Use low power audio grade streaming components. So the thing that brings streaming music into your listening environment, the thing that's connected to your DAC or to your stereo system, that should be low power, not high power. You don't want like an Intel Core i9 that's liquid cooled or has heat pipes running out the sides of it. You don't need a gaming computer or media computer. You don't need anything that's powerful. You don't want anything that's powerful. If it requires more than 5 volts of power to operate, at least internally, you probably need to kind of take a look at your decision-making process and see if it really makes sense. The lowest power, the quietest, lowest energy device, the better. Like the endpoint that I'm using in my primary system, when I'm playing high-res music, it draws less than 2 watts of power. It should draw less than a nightlight if you can get it down to that level. And then you want to prefer balanced connections to RCA connections as much as possible. They tend to reduce grounding issues. I don't think there's a sound quality difference, but grounding issues are really annoying. And so if you just don't want to ever deal with those, if you're able to use balanced connections, then you'll be in good shape. There was a question, why keep the server and storage away from the listening room? There are a few reasons, I guess. I mean, mostly for me, if I go to the listening room, I want to relax. I don't want anything that has that like has a TV screen that shines light in my eyes. I don't want anything that makes adds mechanical vibrations or any kind of even subtle noise that I might pick up subconsciously. If I could, I would turn off Wi-Fi in my listening room as well, so that I'm not bombarded by radio signals. I want it to be as tranquil an environment as possible, and so I want all of that IT equipment, or as much as I can possibly imagine, or as much as I can possibly manage. I want that stuff to be as far away from the room as I possibly can. So no spinning hard drives, no things with fans, no computers that are generating little RF signals, nothing like that. I just want audio components in my listening room. And I want it to be, kind of an audio shrine, if you will. And so that's my recommendation. Now, will there be audible, problems by having these devices in there? We've had, historically, we've had turntables that have a giant 12-inch platter that's grinding away. We're scraping a rock through a groove. Open reel decks have these big motors and, spinning tapes that are in the room. We have CD players that I already talked about that are vibrating and knocking away. And so we're used to having kind of relatively noisy devices in our room, but with streaming and with modern audio, we don't have to do that anymore. And I think it's significant because with digital audio and streaming audio, the noise floor is so low in the music itself. I mean, unless you're listening to older recordings or things that were sourced from analog tapes and that kind of stuff, modern digital recordings, the noise floor is so low that you can actually appreciate the blackness of that background in your room if you're able to get your room quieter than you formerly were able to do so. So I would say that's my reason. If having, hard drives rattling away in the corner doesn't bother you, or you've tried it both ways and you can't tell a difference, at the end of the day, this isn't about you doing everything that I tell you to do or you're in trouble. It's about you enjoying your system as much as you possibly can. And there'll be some things that are obstacles to my enjoyment that just don't bother you at all. And the reverse might be true in some cases also. So what David Blumenstein and I said during our Exponent talk, and it holds true here as well, as long as no animals or small children or elderly are being harmed by what you're doing in your listening room, then you're welcome and free to do it. So don't feel obligated to follow every recommendation that I have. But just know that if you're dissatisfied in some way, some of the points that I'm talking about could be beneficial to you. Home networking must-haves. You got to have a reliable internet connection in order to stream. It's just kind of the way it is. Most people have this as a solved problem, but if you don't, you should either hire somebody or get a friend or a nephew or somebody to come over and help you kind of figure that out. What I will say is that latency is more important than bandwidth. So sometimes people will have a 1 gig or 2 gigabit network connection to their house, but their latency is 30 milliseconds or whatever. If you do the speed test thing, if the latency is not in the single digits, you probably need to take a look at what's going on with your network. For streaming audio, latency is more important than bandwidth. We don't need much bandwidth for streaming audio, but we do care about latency. And then a reliable home network with wired Ethernet to at least 2 rooms. I talk to people all the time who've spent more than $1,000 on the power cables and interconnects in their system, but don't have a wired Ethernet connection to their audio system. And I don't know, it's a little head scratching to me. If you're willing to spend more than, I would say, $100 a pair on interconnects, you just need to hire a low voltage guy or gal to come out to your house and get a network connection near your audio system. Unless you're renting and your landlord doesn't permit it, or you've got some kind of really bizarre situation, it's almost always possible. And I'm always amazed at how These guys are folks who are skilled in low voltage wiring, can get wired to just about anywhere, even though I would think it would be impossible. They're able to find a way to make it work. So it might cost you a couple $100, but I promise it'll be better than a couple $100 on just about anything else you could spend. So that is, I think that's a key component there. And then for home networking, I tell you that I want you to simplify the topology. So I'd like you to get to the one big switch type of topology as much as possible, at least for connecting your audio components. Maybe you've got a coffee machine that's on your network, or a refrigerator, or other appliances, or your alarm system, or whatever. You can connect those however you want to. But for at least for your audio components, if you can get all of your audio components together on one switch that's centrally located, ideally not in your listening room, but you kind of have to do what you have to do. That simpler topology is going to make things a lot easier. The other thing that I would say is to balance your network. I've seen posts from audiophiles where they'll take a switch and then they'll connect that switch to another switch, and that switch to another switch, and that switch. They'll cascade switches like 5 or 6 deep, and obviously creates some bottlenecks in the network. But it adds latency, and network latency is bad for streaming. So I wouldn't recommend that. If you are not able to get everything connected to one big switch, then I recommend balancing the network instead. And I'll show an illustration of how I've done that in my home, just to kind of give you an idea. But cascading switches unnecessarily, you should definitely try to avoid doing. Like I said, unshielded just appears your friend. Stick with Cat 6 or Cat 6A. Those are the two standards that are relevant. There are people asking me all the time about Cat 7 or Cat 8. Cat 7 is not a standard. There's an industry consortium that tried to come up with Cat 7 because it was taking too long for Cat 6A to come out, I guess. But anything that's branded as Cat 7 is probably slightly worse than Cat 6A. Also, Cat 7 traditionally doesn't have RJ45 connectors. I can't remember what the connectors are, but a proper Cat 7 cable is not something you could even plug into your home network. So, and then Cat 8 is for data center stuff. You can buy a Cat 8 cable. You will, unless you're willing to spend 5 figures or more on networking hardware, you're not going to be able to get the benefits of a Cat 8 cable in a home environment. So there's no reason to do it. Unshielded Cat 6, unshielded Cat 6A are what you want to use as much as possible. There's PoE versus EOP. Power over Ethernet is a way for a network switch, to also send power to a connected device like an access point. This is really convenient. If you have ceiling mounted access points throughout your house, if you plug them into a PoE switch, you don't have to run a power adapter to those ceiling mounted access points. A lot of times getting power to your ceilings inconvenient, as I explained at the beginning of this call. So if you can send power down your network cable to an access point, that's great. But there are folks that are doing Ethernet over power, where essentially they use the power outlets in their house as a way to get networking to their devices. And I've never tried it. I've got a friend who tried it, and he had some success with it. It tends to be a pretty noisy connection, and it tends to have as much or more latency as Wi-Fi. So it's think of it as like a little bit worse than Wi-Fi. I can't think of a reason why you would have to do that. If you can possibly avoid it, it would be something to avoid. One of the questions that folks asked about was using their coax connections. A lot of houses, especially older houses, have cable TV jacks throughout their house. Nobody uses cable TV anymore. Almost nobody does. But there's this thing called MoCA that allows you to use those as network connections. So if you had a coax, like an RG6, whatever style connector, I think the RG6 is the cable, not the connector, but you get the idea. If you had this sort of threaded coax thing behind your stereo system and you didn't want to spend hundreds of dollars to have a network cable pulled there, you could look into doing MoCA to get a network connection there. I think the latest MoCA 2.5 spec actually supports more bandwidth than gigabit Ethernet. It is pretty expensive. It costs about $150 per jack to implement this technology. And there's all kinds of stuff you have to do to filter your network so that your local network traffic doesn't leak out into your neighbor's house. So it's a little bit of a pain to set up, but the Mocha standard is something that's worth looking into if you're renting or there's some other reason why you can't run wired Ethernet. It is a possibility. One thing to be aware of is that Mocha shares bandwidth across all the drops. So if you have 10 drops, then the bandwidth is shared across all 10 of them. Effectively, you have a tenth of the bandwidth that you would have just with a single connection. So while a single point-to-point Mocha connection might be more than a gigabit, 10 of them will be slower. And then, like I said, Wi-Fi mesh we want to avoid, and then optical networking I already talked about. So this is what my home network kind of looks like. I know it's really small, but internet comes in through a big router, and then I have this big 24-port switch like I talked about that is at the next layer. You can't see my mouse pointer. That makes me sad. Maybe I can move my mouse pointer over here. Does that show up? Kind of. All right. So this is the big 24-port switch. And then all these other things are like either Wi-Fi access points or they're smaller switches. I have some 8-port switches that are powered over Ethernet. I've got one in my theater, one in our family room. I've got one in the laundry room. I've got a few of these things kind of scattered around. And all of our endpoint devices, so laptops, computers, streaming devices, are connected to one of these endpoint devices, either over a wired connection or, in the case of streamers and servers, over a wired connection. The reason I call this a balanced topology is because every device that's on the network has the same number of hops to get to the internet, and unless they're talking to a device that is on the switch that they're connected to. If local traffic is extremely low latency, but if they have to talk to another device, they all have the same number of hops. And you can tell it's balanced just because if you squint your eyes and look and see that there's just these flat levels. If I had more switches cascading off of that level at the bottom, that would be unbalanced and kind of gross. So ideally, you'd like your network to just end at where we are, this one here, this one big 24-port switch, and then you hang all of your endpoint devices off of there. But if you're fancy, or you're a nerd like me and you need more levels, you can add another layer. And in corporations, they'll add another layer after this. They'll have all these switches maybe be different floors in a building, and then they'll have switches that connect to endpoint devices from there. And so you could add multiple layers to this. As long as it's balanced, the latency is going to be consistent. You'll have consistent performance, and it'll work pretty well. But you want to avoid unbalanced topologies as much as you can. The environment that I'm using and the way that I prefer to offload processing, it'll come as no surprise to anybody here, I wouldn't imagine, is I like to use Roon server for this process. Roon's architecture, I know people give Roon a lot of gripe because they charge $150 a year for their service and all that kind of stuff. And it seems like it's expensive software. I guess so, but in audiophile terms, I don't really feel like it's that bad. Everybody has to make their own judgment call on that kind of stuff, though. The thing to remember about Roon, and I've talked to the Roon founders a fair bit, even on Zoom calls or one-to-one calls, to try to understand, why their solution costs as much as it does and what they're actually doing. And what the president told me was that their greatest expense, besides employee salaries, but pretty close to that, is what they have to pay for licensed metadata. So Roon is principally a licensed metadata service. We take metadata like embedded album art and song lyrics and audio, artist bios and album reviews and all that kind of stuff for granted because you can scrape a lot of that stuff on the internet for free. You can Google a song and get the lyrics to it pretty easily, right? But Roon doesn't want to get in trouble with the music providers, and all those things are licensed materials. The photographs that are on the cover art and the song lyrics, and somebody had to write the artist bios and the reviews. That's all licensed data. Yeah, it would be nice if they had like the original album liner notes. For some Qobuz albums, you actually can get the PDF for inside of the Roon UI. You can click on the PDF and get the liner arts. Qobuz will provide that for you, and it's available through the Roon UI, which is pretty wild. But the problem is, yeah, that all that stuff is expensive. So they spend a not their greatest expense, but probably their second greatest expense is what they were telling me is on this licensed metadata. So you may rip a CD and put it on your server, and then you point Roon at it, and Roon will identify that album. Uh, when it in that identification process, it will match it up to metadata that it has in the cloud. And instead of using the embedded album art that you may have put into those tracks, Roon will display typically a higher quality album art instead that's been licensed by the record label, and they'll also include metadata and credits for that album that are all licensed. So that's where the cost is coming from. I do hear comments all the time that JPlay sounds better than Roon, or that AudioVero sounds better than Roon, and it's true. So and let me explain. I started out my evaluation. I was a big AudioVero fan. I had a laptop or a small computer running AudioVero, and I had a local DAC connected off of that laptop. And I wanted to try out Roon. It was in 2014. I'd heard a lot of things about Roon. It was new on the scene then, so I installed it on exactly the same hardware. I listened to it, and it was terrible. The user experience was not anywhere near as good as it is now, but it was all right, and in some ways it was nicer than AudioVero, but the sound quality just wasn't there. I listened with my headphones. That was the most reliable way to kind of compare the sound for my setup, and it wasn't close. Even JRiver sounded better than Roon did. And so I wrote the Roon guys and said, guys, it doesn't sound good. So, and I'm an audiophile, so I care about that kind of thing. So I'm not going to use this. And we went back and forth, and they wanted to know about my system and my setup and all the rest of that stuff. And, after I kind of gave up on it, after a year went by, I decided I would take another look at Roon. And I was talking again to maybe it was to a different engineer or a different salesperson, but once they kind of got into the details of my setup, they said, well, you can't install Roon the same way that you install, and I played around with JPlay a little bit as well. I found JPlay has gotten a lot better. I found JPlay to be just a little bit too Spartan in the way that you interface with it. I know it's gotten much nicer now, and so the UI looks in many ways as good as Roon, but it was pretty terrible back when I was trying to use it. It sounded fantastic, especially in hibernation mode, but just was dreadful to use. And he said, well, you can't just install Roon on a laptop and or a computer and have a DAC connected to it and expect it to sound good. That's not the way it works. I said the Roon's a music server. So think of it like an IT component. It needs to run in a server closet. It needs to run someplace not in your listening room. It needs to be on your network. It needs power, and it needs networking. It doesn't need a keyboard or a mouse or a display, but depending on what operating system you're running, it can run headless, but it should not have a DAC connected to it. Even the Roon Nucleus devices that Roon sells for upwards of $4,000, they have USB ports in the back. Those USB ports are not in any way optimized for audio use. They're for connecting mass storage devices. You can connect a DAC to it, and it will make noise. It's not going to be necessarily good noise. So what the Roon guy said is your problem is you've implemented our technology in a way that's contrary to how we've designed it for sound quality. So to get sound quality out of Roon, you have to run all the processing on a dedicated computer someplace, and it doesn't need to be an expensive computer. The most popular computer that I've been setting people up with lately costs less than $140, and it performs wonderfully. Little headless device. It takes 12 volts of power, and you connect up a network cable. My next door neighbor has one. It's in his little network closet in his laundry room, and it's literally just suspended by the network cable. It's so lightweight that you can just hang from its network cable, and it's perfectly happy like that. But you need to have a dedicated computer that Roon runs on that has nothing to do with your audio signal path. And then you have an audio grade component, like maybe a $20,000 render or Inuus or any number of devices now that are Roon ready or not. That those are in your audio rack, and maybe it's a streaming transport that goes out to an external DAC, or maybe it's a streaming DAC but a very nice one, and Roon will sound as good as that device is because the server is elsewhere. If you have a DAC connected to Roon, or if you have the Roon server in your listening environment, then it's going to sound pretty terrible. Where JPlay and AudioVero in that same configuration will sound great. Roon's just not designed to function that way. You have to have the distributed topology to get sound quality out of Roon. All right. My environment, I've got a Roon server that's under the stairs. I've got networked endpoints all over the house. In my primary listening room, I have a pair of Legacy Audio Focus XT towers and a nice DAC and analog preamp. And a few feet away, I have a little Raspberry Pi that is running an operating system called Audio Linux. It's a not free operating system that uses a real-time kernel. It's based on Arch Linux, but basically I wanted to try an operating system that had some audio credentials. It cost like $80 or something like that, so it's not very expensive. And then Roon just streams audio to that, and I can log into this little Audio Linux device and see how busy it is. And it routinely stays 99% idle. The CPU is not doing anything at all. All it's doing is copying unencrypted, uncompressed audio frames from the Ethernet port to the USB port, and it just sleeps the rest of the time. And the sound quality, in my view, and then everybody that I've invited over, they just cannot believe how good things sound. If I'd implemented Roon any one of a number of ways, if I had a Mac Mini in the room connected to a DAC, it would still sound pretty good, but I don't think it would sound as good as it does the way I've implemented it, because I'm using the distributed technology, and I'm using the inverse square law to keep the DAC and the computer separated, and the server is on another floor. Assuming I'm not using any DSP stuff. Oh yeah, I use a lot of DSP. So I use digital room correction. I'm using 66,000 tap FIR filters that I created using software from a German guy called Uli, from a company called AudioVero. It's called Acourate, and I'm able to use those filters to not only linearize the amplitude response of my system, but also the time domain response. And it sounds amazing, and there's an obvious difference with the solution turned on or off. Roon is implementing those filters. Roon can't build filters for you, but it can implement them using its convolution engine. That's part of its DSP processing. And I actually have filters for a number of different rooms and setups throughout our house. And for all of my headphone setups, I'm doing 66,000 tap headphone correction filters. I'm able to apply unique filters for each room that is in the house. The other thing that's a little bit crazy, and I know we're running a little bit long, but I have a Rega Planar 8 turntable with an Effeta 3 cartridge that I use occasionally for listening to vinyl. And I stream that through Roon as well, so that I can get either room correction or headphones correction. And my Roon server handles all the DSP processing for that also. The other thing that's crazy about Roon's DSP engine is that if you feed it a sampling rate for which you do not have a filter, filters have sampling rates as well associated with them. If I play a DSD 256 file in Roon takes that DSD 256 file that's a 1-bit file, and it upsamples that to 64 bits. So now it's like, what does that work out to? 11 megahertz is the sampling rate, and 64 bits would be the bit depth. And then it upsamples my room correction filters as well, so that I have a room correction filter that's now 2 million taps or something crazy like that. And then it uses a delta sigma process to convert that 64-bit format back to a single-bit format, so that I can send DSD with room correction to my DAC without converting ever to PCM. And it uses a lot of CPU resources. I'm using a Core i7 processor, 11th gen Core i7 for my Roon server, and the fans go crazy, and it's really busy when I'm playing those DSD 256 files. But I don't hear any of that because it's in the closet under the stairs. Unless I go under the stairs for some reason, I'll never experience that noise. And the DAC that I'm using, and the little Raspberry Pi has no idea that I'm doing any processing to the signal at all. All it knows is that it's getting either DSD or PCM stream over the network, and it just copies those to the DAC. It takes no more processing on the endpoint, whether I'm doing DSP or not, because the workload is completely separate. All right, let's see. T-Mobile broadband is about 25 milliseconds. Yeah, for a 5G connection, 25 milliseconds is pretty good. I mean, it'll probably be okay. Like I say, if you can get get into the single digit range for latency, you're just gonna have fewer problems. What's the audio benefit of going to an ISP that offers less than 10 milliseconds or less? Yeah, I think it just comes down to reliability. So lower is better. On a good day, my ISP gives me 2 milliseconds of latency, but it may depend on, when I'm using speed test, how close the thing is that I'm testing. If I'm testing an Ookla site that is in downtown Phoenix, it'll be a little bit longer. Let's see. Endpoint only sees unencrypted audio streamed via Ethernet. Yeah, that is correct, unless the endpoint is connecting directly to Tidal or Qobuz or whatever your music service provider is. In that case, or if you're using Tidal Connect or Qobuz Connect, then the streamer's managing that TCP connection out to the internet to your provider. And so it does have to decrypt the audio stream, and it also has to uncompress it. So we want to avoid that if we can. Anybody want to, let's see. But if Tidal or Qobuz is coming in via, so the nice thing about Roon's architecture, again, is that Roon maintains the connection to your streaming provider, currently Tidal, Qobuz, or KBOC if you live in Asia or wherever. And so Roon handles all that encryption and decryption. It handles taking the FLAC stream and converting it to raw PCM samples. There was a big debate a long time ago, and some people still talk about it, that they prefer to keep all their music in WAV format instead of FLAC because WAV sounds better. That might have been the case before, but it isn't anymore if you use this distributed technology, because all your FLAC files, the server will uncompress them to PCM samples and send them to your DAC. Your WAV files, they don't need to be decompressed to PCM samples, so the Roon server will send them to your DAC. Your DAC has no way of knowing that the server is sending it a FLAC file or an ALAC file or even an MP3 file. It has no idea. All it knows is it's getting 16-bit 44.1K sample rate PCM stream that's uncompressed and unencrypted, and it just plays it out locally. So yes, if you're using Roon and you have a separate Roon server that's not connected to your audio system in any way except via networking, then that processing is happening outside of your room. Explain the difference between Roon and JPlay for library music versus something like JRiver. Roon and JPlay are a lot different, I think. JRiver has a concept of a metadata database, but it relies pretty heavily on embedded metadata. So when I say metadata, I mean metadata literally means data about data. So that would be like embedded album art or loudness, volume leveling characteristics like R28 metadata that tells the player how to handle variations in loudness from one album to the next and so forth. Or obviously the information about the recording, the artist, the composer, the track name and the album name and the year and all the rest of that stuff. JRiver tends to rely on the contents of the file to provide that information to it. It does have a concept of an external library, and so external metadata database, and so it can have some information that basically overrides what's in the file or that is in addition to what's in the file. But JRiver is pretty heavily dependent on managing files directly. And if you make a change in JRiver, typically it writes those changes back out to the file, whereas Roon never, ever modifies your local files. Roon has a metadata overlay concept instead, where It will try to identify your albums and match them up to its online metadata database, but it will never modify your files. It just maintains the association between your albums or your files and the metadata database that it has online. Less concerned with metadata, more concerned with sound quality. Yeah, so for sound quality, that's me too. I mean, I love the rich kind of experience that you get with Roon. And I could show, we're running a little bit along on time, but I could show you kind of how I like to use Roon to find new music. I think the tools there are pretty powerful, and they're getting more powerful all the time. But sound quality has to be there, right? That's why I rejected Roon when I started evaluating it at the beginning, because I didn't like the sound quality compared to more sort of clunky solutions that I had, like JRiver and Audiophile and my limited experience with JPlay. But if you deploy Roon the way in the distributed method that I've suggested, you get sound quality, and the sound quality is really only limited by the quality of the audio component that you have in your audio system. So the streaming transport, or the streaming DAC, or the streaming amplifier, or the streaming speakers. Roon can deliver the audio data to those devices in a bit perfect way, or you can use Roon's advanced DSP to improve that data, enhance that data beyond what the capabilities are of the device you're using, and overcome any limitations in your room. But Roon is no longer a limitation to sound quality as long as it's implemented the way that I've described. I'm just going to attempt to show the Roon UI, and just let's see if this takes. There we go. To just show really quickly a couple of things that I found that are useful that not everybody is aware of. If I go to, let's do Sheryl Crow. I'm going to look at the artist real quick, and I'm going to open this album in particular. So the album art here and all the rest of the stuff that's being shown is something that is because this album was identified. This is from Roon's metadata instead of my own. I could edit the album and tell it to use my embedded album art instead. I've got 500 pixel wide album art, but the artwork that Roon has is 1,000 pixels instead of 500 pixels, so it looks nicer. But I could override it for some reason. I had some special art that I cared about. What I wanted to show you, though, is the credits section. We can see different people who performed on the album, but if I scroll down a little bit, I can see that Bernie Grunman did the mastering for this album, which is probably why this is the only Sheryl Crow album that sounds good. I'm sorry if you're fans of the other ones. There might be some other ones that sound pretty good. So there's Bernie. If I click to Bernie's discography, I can see that he's worked on 2,113 other albums, and I can sort those albums by popularity, where popularity is determined using Roon's algorithms and collecting sourcing data from Roon subscribers. But at least among Roon subscribers, the most popular album that Bernie Grunman ever worked on is Dark Side of the Moon. But I could sort them by date if I wanted to. So the oldest one that they have in his library is this Art Pepper album, which I love. If you scroll through these things, these are all fantastic albums. And many of us haven't heard all 2,113 of them. But if you're looking for something that sounds good, a lot of us, we claim that we're music first audiophiles, but the reality is that we like stuff that sounds good. We may develop a taste for the music over time if we haven't experienced it, or if it's not something from our youth. These are worth checking out. I guarantee you that every single one of these is going to sound really, really good. But the cool thing is, if I go to my albums section, I can use bookmarks to maybe bookmark albums that I suspect are recorded by people who know what they're doing as far as mastering or recording. So I've put a filter in there looking for albums in my library that were worked on or engineered by Bob Ludwig, Doug Sachs, Bernie Grunman, Al Schmidt, Al Nishida, Bob Katz, Dave Collins, Rudy Van Gelder, Steve Hoffman. And I could negate these things or make them positive or whatever. And then I could just sort by, most played or whatever else. And I can, go through if I just want to hear something that sounds good, or maybe I'm doing a demo and I want to play something that I know is going to sound good. Like this Aaron Neville album sounds amazing. It was worked on by Bernie Grundman and probably contributed to by some of these other folks. The Gregory Porter album. It's amazing how tools like this can help you to kind of sift through the over 100 million tracks that are available on streaming services to find stuff that actually sounds good. And that's something that we care about. But I mean, you can use it for other ways. Maybe this is a bad example. Maybe if you're looking in the credits here, maybe you really like the bass player on this album. You didn't remember that it was John Clayton who did the bass. You also have Christian McBride on here. You can go and hunt for albums that John Clayton played on. And he's got a few made albums, but he's done a lot of collaboration with other folks. So he did 10 albums with Diana Krall, and he's done some with Mitt Jackson and Count Basie and so on and so forth. And so if you like a particular artist's performance, you can kind of track them down. I don't know how you do that with JPlay. Maybe you can, but I don't know how. And so this is the kind of stuff that tends to make me excited. And then if I'm playing one of these things, I'll just grab something and play it here. This is going to a headphones rig that I have downstairs. I'm using the AES EBU output of this particular device. It's not actually Hi-Fi Berry, but pretend like it is. The company that made it just didn't bother getting Roon certified. But I'm using a EQ for focal radiance to make my focal radiance headphones sound as nice as they can. And so if I go into the DSP settings, I can see that this is the response curve that is being applied to my headphones. There's a guy named Oratory1990 who does a really good job with headphone targets. And so he has a Harman target for my headphones. And you can see they don't need a lot of EQ. They're pretty flat headphones. I mean, there's a little bit of maybe 6 dB of adjustment, 125 hertz, just because they tend to be a little warm. But I can make these things sound amazing. And I could choose any number of other filters as well. And if I have other headphones, we've got the Bathos, the Select, the Utopias, like every headphone in here, and in a lot of cases, there are multiple presets that are available for these things. And this you just get with your Roon subscription. To be clear, this Opera database is an open source thing, so Roon didn't come up with this data, but they've incorporated it in a seamless way in their user interface to make it just sound really nice. Just a couple of things about Roon that you might not have figured out. Another pro tip that I've started to use a lot more is I'll go to the album section. Let me go clear all these focus filters here. If I'm just looking for a particular album to play, there's a magnifying glass up here that you can search for Sheryl Crow, and you saw that I did that. But if I do it here, it's way faster because this magnifying glass over here is just filtering what's in my library rather than like 110 million tracks on streaming providers. And so my go-to now, if I want to search for something, is to use this magnifying glass instead of the one up above. People recommend using an iPad. Yeah, iPad is a beautiful Roon remote. I've got 3 Google Pixel tablets, and we use those as well. YouTube sound quality, it can be surprisingly good, I would say. I'm going to switch back to the deck here. YouTube sound quality can be surprisingly good, but I don't know of a way to offload the processing for YouTube. I guess Chromecast a little bit, but any kind of cast technology heavily involves the device to which you're casting. In other words, that device ends up handling the encryption and decryption, the TCP connection to the streaming service, and all of the stream uncompression. I think YouTube uses AAC or one of these other codecs, and so that audio format has to be uncompressed to PCM samples before it can be sent to the DAC. And your endpoint device is going to be involved in all that processing. But honestly, YouTube, I'm not aware of any lossless audio codecs that YouTube uses, and so probably the losses introduced by that codec are going to be on par with whatever you're losing by having to have your endpoint do all the extra processing. So it's kind of a wash. I think it's useful to have a device that can play YouTube music in your system and even YouTube videos just for fun. But it's not something that I would recommend using for critical listening, probably, if you can find the same music in a lossless format someplace else. For somebody who wants to start with, is Roon Nucleus the best starting point? I would say the Nucleus one for $499 is pretty good. It's about the price of the Roon or the Intel NUC and I guess Asus NUC now devices that I used to build for people. I've built probably around 15 or so for different people. It's about the price of that. If you don't mind doing a little bit of DIY, email me after the show and I can talk to you about the $140 solution that I've been recommending. I've got about a dozen people now in the field that are using that solution as well, and they absolutely love it. If you have a library, a local library that is less than 100,000 tracks, you'll probably be delighted. It's about 80% of the speed of my my 11th gen Core i7 device. So it can't quite play the DSD 256 albums with my room correction filters, but it can play DSD 128 all day long. And it handles library sizes, like I say, up to 100,000 tracks really, really well. And it's $140 instead of $500. I mean, the Roon solution's fine, but it's not any better than the $140 solution that I recommend, except that it's officially supported. And the $140 solution that I have is kind of not officially supported. If you have a library of over 100,000 tracks, then you need a more powerful computer. So depending on how large that library is, I would recommend definitely a modern Intel Core i7 or i9 processor. And there are plenty of devices out there that will run Roon I mean, there are people who have on the order of 1 million tracks, 750,000 tracks I've heard, and it's not a problem. It's not a problem with these more powerful computers, but you need memory and you need processing power for a lot over 100,000 tracks, and the more over, the more it is. Roon doesn't use memory gratuitously, so if your server has 16 gigs of memory and Roon only needs 4 for your library, then it's only ever going to use 4, and the other 12 will just kind of sit there and not be used. But if Roon starts crashing all the time, probably your library is too big and you need a system with more memory. I haven't heard of anybody who needed more than 16 gigs of memory in their Roon server, but maybe there's somebody out there that does. And fortunately, memory is incredibly inexpensive. So if you're building an i9 box for your million track library, memory is going to be the least expensive component that you put in that box. Let's see. Somebody said...
Sorry to interrupt. Jim Hunton had an issue with not having enough memory and had to go with 32 gigs of memory to run Roon.
Yeah, that's the first I've heard of that, but it can happen, I guess, if you have upwards of 1 million tracks. And you can get I mean, they don't have to be local tracks to use resources in Roon. So if you're on Qobuz and you basically favorite every album in their entire library, I guess you could get to well over 1 million tracks pretty quickly that way. You don't necessarily have to have them locally.
I had the original Roon Nucleus, and it only came with 4 gig.
Right.
I bumped up against the problem until I opened it up and replaced the 4 with an 8. And I think 8 handles my 150,000 tracks, no problem. And the only thing I did was I offloaded my Roon server to a totally different environment where I'm running an M1 flavor of an Apple Mac Mini as my core. And then I'm using a server called the Grim MU1 as my actual player. And that made a big difference. And I talked to 1 or 2 other people who said, yeah, offloading definitely helped for various reasons. Some were speed. Others, in my case, it was speed is what I was looking for. But I also got better sound quality, which surprised, the guys at Grimm. Of course, they wouldn't want to admit that their product isn't quite as good. But I think it may also be the operating system. They're running Tiny Linux. This is Apple's own implementation of an OS. So maybe there are advantages there. You just never know with this stuff.
Yeah, no, you really, really don't. But you touched on an important point. That it's that offloading of processing that pays dividends in a lot of cases with people's systems, and getting that processing as far away from the endpoint as it can be, even if Grim Audio or Inuus or whoever it says there's no need. Our device has sufficient internal isolation. There'll be no problems. I don't think you can go wrong by moving the processing off of their endpoint.
I even replaced the footers underneath a couple of my devices, and they made differences. But it was because I talked to the guys at HRS. I can't remember his name. He's the guy who runs the company. He says, "Yo, try our Vortex. I'll ship them to you. Give it a try." My God, what a difference it made putting it underneath anything that had a crystal, anything that had its own clocking, which included my Ether Regen. It included the Grim, and it included my DCS Apex DAC. So that all made a difference. I mean, you just never know. It's sort of like reducing noise in your system.
Yep.
Once you play around with things and you say, "Oh, where did that stuff suddenly come from?" And it's music. It's not noise.
Sometimes you don't know that you have a problem until the problem is removed, right?
Exactly.
So
Yeah.
and I think that kind of stuff brings some fun to the hobby. And like I said, if you're not harming anybody else and you can afford DCS Apex stacks and things like that to experiment,
Yeah.
then absolutely knock yourself out. I want everybody to have fun. What I don't want is for people to get frustrated and they can't, like, they turn their system on to go listen to music one day after work and it works, and they come back the next day and do exactly the same stuff and it doesn't work because there's a networking topology problem. I don't want people to have to suffer that. And then, they send nasty notes to Roon saying, "Your solution sucks. I can stream Netflix all day long, but I can't stream audio from my office to my listening room. Why is it?" And it's not Roon's fault. It's because you have a broken ass network. Sorry, forgive my German, but like, you have to fix that stuff or it's not going to work.
Parenthetically, I work with a lot of senior citizens who, are not happy with technology, especially when software or hardware changes without them knowing about it. But then I have the same problem at home where suddenly AT&T has screwed up my fiber network. So I'll have to go through the process of powering down everything and starting from scratch and giving myself 15, 20 minutes, bring everything up, and suddenly everything's working again.
Yeah, those are, unfortunately, especially if you're streaming from the internet instead of from your local NAS, you're going to have those kind of things. But you could have problems from the NAS too. The NAS could throw a drive, or it could get hung up on software. And so I want everybody to have a streaming experience that's as reliable as a CD. I know that that's an impossible goal, but there are certainly some things you can do to make the process easier and get closer to that. Somebody asked about if Macintosh and other people make good digital gear. I don't have any experience with Macintosh's digital solutions in particular. I will say this, though. There are companies that I know, Eversolo and some other companies, that will embed the Android operating system into the little computer that's in their streamer. I'm picking Android as a specific example, but you could use anything. Android 16 just came out. I have it on my phones and on my tablets. But on streaming devices that have it, I'm only at Android 11, or sometimes older than that. And at some point, Google will stop supporting those devices. Google typically supports their own devices or third-party devices for a period of 5 to 7 years. After that, they don't provide any OS updates. If you don't get OS updates for long enough, at some point, the applications that are running on them won't be possible to update those either. And so you end up with, at some point, a doorstop. Like, all streamers have a shelf life. Unlike a CD player, it'll last as long as the laser lasts, and as long as the little, motor keeps spinning the disc around, you can keep using the CD player. But streamers, think of it like, if it's a really nice streamer, you might get 7 or 8 years of good support from a software perspective. Software for streamers is more important than hardware. And going back to the question of Macintosh, like, I don't think of Macintosh as a software company. They're a hardware company, and they make amplifiers that last maybe upwards of 100 years. But I don't know about their software side. I assume that they're outsourcing their operating system development and their application development to a third party, or maybe they brought that stuff in-house. But at some point, like, they'll have to age out the older components. You can't support software on the same platform for decades. You just can't do it. Even Sonos, you'll notice, if you've had Sonos products in your house, had to drop their older components. It's just kind of the way this goes. And so I would be reluctant to spend personally 4 or 5 figures, especially on a streaming device that I know is only going to last 7 years. So I tend to recommend that folks think about their streaming transports kind of like they do their smartphones. So these things have a shelf life that's shorter than your other audio components, probably. And so you want to try, if you're trying to optimize value in your system, you want to think more cheap and cheerful with good software support for your streaming devices. For your DAC, you can spend more money on your DAC. You're probably going to get more mileage out of your DAC. And then your preamps and your amps and your loudspeakers and your room, it goes on down the chain. The closer you get to your ears, typically the more resilient the device is to needing to be updated or replaced. But yeah, these networking and computerized components tend to have a pretty short shelf life in single-digit number of years. So just think about that as you're making those investments.
Hey, could you mention again the DSP room correction software you're using, as well as the Linux software for Ethernet to USB that you were talking about?
Yeah, sure. I'll put it in the chat, but it's Acourate. ACOURATE by Acourate by AudioVero. And the reason I'm using Acourate is because I actually was fortunate enough to be on about an hour and a half long phone call with Bob Katz in Florida. He's a mastering engineer, and he likes Acourate. He did Acourate. He did a lot of the mastering for Chesky albums back in the day. Super nice guy, and he said he's tried all kinds of room correction solutions for his mastering studio and for his listening environment, and all of them made the sound in some ways worse, particularly in the time domain, and that was unacceptable to him. And he knows a fair bit about DSP. He's designed and built DACs. He's done all kinds of crazy things. He said Acourate was the first one that there were no characteristics of the resulting sound that were worse than the uncorrected sound. And then there were quite a few that were a lot better. And so I figure if it's good enough for Bob Katz, it's good enough for me. So that's why I've stuck with it. As it turns out, it's the most expensive solution for building filters for solutions for software like Roon and Audiophile. It's on the order of $500, where a lot of other solutions are in the sort of $200 or $300 price range. But I could do another 2 or 3 hour talk on Acourate. I won't do that tonight, but it's a wonderful solution. And then the operating system I'm using is Audio Linux. It's based on Arch Linux, which is the second least user-friendly operating system, Linux-based operating system that exists that I'm aware of. And so it's I wouldn't say it's super tricky, but it's not for the faint of heart, I guess. But I don't know that I could tell you that it sounds for sure better than Diet Pi or RoPi or some of the other popular solutions. But I felt like as a credentialed network audiophile, I needed to have at least one audio-focused operating system running in my environment, and that's what I use. I haven't done a lot of careful A/B comparison, but it's worked flawlessly. And every time I turn my system on and hit play, music comes out. And that's my minimum requirement for success for something like that.
Anyway, I have one of those Weem Pro Plus, the 896E.
Yeah.
And it seems to be doing just a very good job. I have Crown electrostats, and I have a BAT amplifier preamp, in which I was told use a preamp over the integrated digital preamp thing. Use a primary preamp. But my question is, and I was told that by the builders of BAT, by the way. But my question is, I'm using a 35-foot Ethernet cable directly from my AT&T server with a Cat5 cable, and it seems to work just fine. Would I get improvement by using a 6?
Only if, I'm trying to think, between 5 and 6. No, the bandwidth, if the bandwidth is from the Weem device is limited to 100 megabit.
Yeah.
And your Cat5e cable is capable of gigabit speeds. I need to look at it and see, at least to 40 meters, but maybe to 100. I think Cat5e can do gigabit at 100 meters, at least 40 though. So as long as you said your cable's 35 feet, so it's less than a third of the most pessimistic bandwidth estimate I can come up with. So I don't think you would have any problems, and you would only benefit if you notice that there were problems. Now, I've had bad network cables before that were bad for reasons other than the technology used, and you would know pretty quickly.
No,
have
it's
this problem.
working.
So I
just
don't.
fine.
I would say don't upgrade your network cable. Instead, go buy an album that you like.
Yeah, because I have to crawl to the house to do that, and I don't like that.
Yeah, don't. Especially if your cable's platinum grade or outdoor grade and it's running under your crawl space, I would leave it alone and be glad that you
Oh.
have it.
It's all mounted up against the studs underneath there, so it's not even sitting on the ground.
All right, good job. I think you're in good shape. You got other places where you could optimize, but that's a place I would leave alone. Any opinion on using Roon Arc? So Roon Arc I use in my car. Like every time I get in my car, we have reasonably modern Volvo cars, if that's a thing, that have thankfully Android Auto implemented in them, and so literally every time I start my car, it's streaming some music from my collection into my car, and it sounds great. We have a T-Mobile connection for mobile broadband, and that seems to be sufficient to get music to come out of our house. It's not most of the time losslessly. I have it configured to use whatever OGG 256 compression that Roon uses. So Roon is taking the music and shrinking the size a little bit to make sure that it doesn't use up too much mobile data and that it's reliable, even if the mobile data connection's a little flaky. But it sounds, good enough for car use. I mean, what is the signal? What is the noise floor in a car? It's like 70 or something. So
my tires will kill you.
It doesn't need to be that good, right? So it sounds fine.
Better than AM.
Yeah, and Roon Arc is nice. It does things like volume leveling. So if you're listening to Britney Spears and then you listen to Rachmaninoff, the volume level's not giantly different between the two. If you just shuffle your entire library or do weird things like that.
Hey, David, I bet you
All right,
the only guy that probably rides around in a car with a Class A B amplifier instead of a D.
That's a hot car.
You have like a Lexus with a Levinson amp in it or something?
No, it's a Moscone. That's the name.
Okay.
And it does sound way better than a lot of those Alpines or cheapy Pioneers or the cheapy, that kind of thing. It makes a difference.
Oh yeah, yeah. I agree with Oliver. It would be nice if Roon had. Audiophiles, we don't like dynamic range compression, but sometimes it would be nice. Like if you're in a car or you're jogging or you're operating a jackhammer or something, you might want the volume range to be kind of squashed. Volume leveling is extremely useful feature for kind of keeping music from different albums so that they sound more or less the same. I recommend volume leveling and use it in all of our environments. I don't find that it reduces the sound quality at all. It does prevent Roon from streaming in a bit perfect way, but if it's implemented correctly using R128 data and with a reasonable target like -18 LUFS, this is all kind of nerd stuff, but if you set up all that stuff correctly, you don't end up with any clipping or any loss in resolution. You do have to turn the volume level on your preamplifier up 6 or 7 dB to account for what volume leveling is doing. But if I have a friend over and he or she's playing random music from their playlist to evaluate my system, we don't have to touch the volume control on my preamp at all. They can play these different songs and they all come out at a reasonable level. So it makes the experience a lot nicer than not having volume leveling on. But volume compression for noisy environments, especially with Roon Arc, would be a nice feature. And it wouldn't surprise me if Harman funded that feature at some point. Zoom host, everybody, thank you for your attention. I've run 18 minutes past. I appreciate you sticking around to listen to all this stuff.
Well, I want to thank everybody for being on this call with David Snyder. Very informative. Any last thoughts anyone has?
I just have one. At the beginning, thank you, David, was quite insightful. You indicated at the beginning how to make things as easy, as LPs or CDs. But the presentation has just confirmed what I've always thought. It's just difficult and painful with streaming. Yes, I do it. Yes, I have it. I have thing in a closet but every time there's an issue, a small update, I don't have music or there's some problem. There's always a reason why there's a problem, but I don't care. It's just a problem. I just want to listen to music, and these have shelf lives. You can put on a 16-year-old LP with totally modern record playing equipment, and it works. It just works.
I agree. The goal would be to get streaming to be as reliable as that, and it's one of those goals that we asymptotically approach, I think. In another talk, I could describe how to make the problem as simple as possible. And in real short words, that $140 small server that I recommend, it runs a stripped down operating system that is only for Roon. You can't log into it. You can't do anything to it. You can't update it. It just runs as an appliance. If you need to turn it off, you hit the power button, it shuts off in less than a second. If you need to turn it on, you press the power button again, it turns on in just a few seconds. And so it just runs as like an appliance. If you run Roon server can run on Microsoft Windows, it can run on Mac OS. People talked about running it on like a Mac M1 or M4 Mac Mini or whatever. But if you use a general purpose operating system, now you have to deal with Microsoft Patch Tuesdays or whatever Apple does with updates. And sometimes updates change the way the networking works, and all of a sudden the sound doesn't work anymore. The thing mysteriously reboots. If you use the appliance approach, then it's dirt simple and you have less futzing around. And then, like I said, the Audio Linux example for my endpoint, it's again an audio focused operating system that intentionally doesn't update itself. And so it just kind of runs quietly in the background and I never have to reboot it. If I do have to power it off, there's a power button I can press that'll shut it down in a few seconds, and then it'll turn back on almost as quickly. So same appliance approach as the server. And if you take those approaches, I work on computers and networks all day long. I don't want to have to do that after work and deal with that stuff. When I want to listen to music, I just want to hit play and have it work. And so far, 100% of the time, that's what happens. But it's because I've taken the time to simplify my network, make sure that the server and the endpoint are isolated, and they're running on dedicated operating systems that aren't subject to updates and other kinds of stuff. So you can get pretty darn close to there. You'll never match a vinyl, but I mean, I have a turntable, and I don't know. I guess when I was reaching for something, I eventually somehow scrubbed my sleeve against the cantilever and the stylus, and bent the cantilever in half. You can make a record player not play well, also. And I don't remember doing that, but it cost $2,000 to fix. Which is much less aggravation than I've had from streaming. So, your mileage varies depending on what you're dealing with.
Yeah, I guess it does.
All right. I think we're done.
David.
Thanks, David.
Thank you for your
Thanks
time.
for being such a wonderful audience. It's been great to see some familiar faces after all these years.
Indeed. Good to see you.
All right. Oh, somebody's asking for my email. You may share my email address when you post the recording for this.
Okay.
And you've got it in the channel as well. So if you've got more questions about room correction or other things, send me an email. I generally respond in a day or so. Just be patient. But I'm happy to help any of you get further along than where you are now, or just to chat about what you got going on.
You didn't change your cell, did you?
No, sir.
All right, then I'm not going to look.
Yeah.
Okay, everybody. Thank you so much.
Have a great night, everyone.
Take care.